Assalamualaikum and good day. My name is Amira Natasha, and today I will present my individual project for the big data in a practice one. This title of my project is a log file analysis using a Hadoop MapReduce. This project focused to understand how a big data can be processed using a distributed computer concept, especially using a Hadoop ecosystem tools such as HDFS, MapReduce, and Yan. In this presentation, I will be explain problem background, objective, dataset, program flow, technique implementation, output analysis, and live demo explanation and conclusion. This scope of project is to aim implementation and a Hadoop MapReduce program to analyze a web server log file. The program process a log data in the distributed environment that using a single machine. Hadoop HDFS is using to store the data, MapReduce perform the computation, and Yard manage the execute resource. Through this project, I aim to demonstrate how a big data system handle the data distribution, a parallel process for tolerance and scalability. In a real-world system, server continues to generate a large volume of log data every day. When the size of log file increase, traditional tools such as spreadsheet or manual script become a slow and ineffective. Manual analysis is also prone to error and cannot scale when the data grow into the gigabyte to terabyte. Therefore, there is a need of an introduced process solution that can handle large data set efficiently, which is where Hadoop MapReduce become useful. The first objective of this project is analyze a server log file using a Hadoop MapReduce. The second objective is a count the frequency of a HTTP status codes such as 200, 302, and 404. The three objective is understand how MapReduce process data in a parallel across a multi-node. Lastly, the project aim the standard practice understand of a Hadoop job expectation from the input and output. The dataset used in this project is web server log file named log text. It contains a 5 log record, and each record include the information such as IP address, timestamp, HTTP request, status code, and response size. Even though the data set is small for the demonstrate purpose, the same MapReduce logic can be applied to millions of log entire in a real production environment without modify the program logic. This help demonstrate the scalability concept of big data system. Hadoop MapReduce is suitable for the processing large dataset because it support automatic parallel execute, a fault tolerance, and scalability. If one node fail, Hadoop can automatically rerun the task of on other node. MapReduce is commonly used for the batch processing task using a log analysis, indexing, and data aggregation. In this system, the output file name a log text in upload into the HDFS under the directory user HD user input. The file contains a 5 web log record, and each record represents one HTTP request made to the server. When the MapReduce job in execute using the code Hadoop jar log analysis jar, Hadoop read the log test file from the HDFS and divide into the logic input split. Each split is processed by the log mapper class. When the system read each log line, extract the HTTP status code using a string parsing and emit a key value part in the format status code 1. For the example, if the system detect a status 200, its output is 201. During the shuffle and a short path, Hadoop automatic grouping all the identical status code generated by different map tasks such as a grouping all 201 value together. This group result are the pass to the sum reduce class, which sum all the value to calculate the total frequency for the each status code. Finally, the reduce write to aggregate result into the output directory user HD user output in HDFS, where the final output file show the total count of the each HTTP status code. This diagram shows the execute flow of log analysis. MapReduce program The input the file log text is stored in the HDFS under user HD user input. When the job is executed using the Hadoop jar command, this file is processed by the log mapper class. Each mapper read one log line, extract the HTTP status code and output the key value pair in the format status code 1. Hadoop then a performance shuffle and a short the group or the identical status code together. The group value are sent to the summary reduce class, which sum the value to calculate the total count for the each status code. Finally, the result arrive HDFS in the file pipe R0000, showing the frequency of each status code. In the log analysis program, the mapper logic is implemented inside the log mapper class. The mapper using the map method to receive each log line as a text input. This line is tokenized using the split function and the HTTP status code in extract based on the fixed position in the log format. The execute status code is converted into int variable key and emit together with a constant value of 1. This design keep to the mapper lightweight and avoid unscaled computation, ensure the fast parallel process across a multi-map task. In this program, the reduce logic is implemented in the summer reduce class. This reduce receive the interval list of int variable writable value for each status code key. A local counter variable is used in entire through the value of commuter to total count. When the when the summation is complete, the reduce write the ingrid result as a final key value pair into the Hadoop output contents. This ensures that each HTTP status code appear only one in the output file, which is a total frequency. This technique implementation, this process begin by compiling log analysis Java with the Hadoop class path to include a requirement library that a compile class are packaged into the jar file distribute across the cluster. The input log file to upload to HDFS using the user HD user input using the DFS put. Since Hadoop only process the data stored in HDFS, the MapReduce job is the execute with the Hadoop jar submitting into the yard, which handle task scheduling and resource allocate automatic. Finally, the output is viewed using the HDFS cat. Results show HTTP status code 200 account most frequent identificating success response dominate the server log with flow reflection of client error. The program following the standard and MapReduce authentication, the map press each log entire to extract the HTTP status code in emit account of one. Hadoop performance shuffle and assort to the group identical status code. The reduce agrange that value a compute the total accuracy for status code. The drive configure the job and the submit in the yard for the execution. Explanation for the status code of 200 occurring two times, such as request, successful request. Status code 302 acquired one time for redirection. Status code 404 occurred one time, client error no fault. Analysis, MapReduce correctly count the frequency of each status code, demonstrate and distribute a computation of a key value, easy scalability to much large data without a changing programming logic. This execute of a program involving several Hadoop command line operation. Input file is uploaded into the HDFS using the code to ensure the data is scalability by cluster. The MapReduce launch using the Hadoop jar log analysis jar, which trigger the driver class entirely highlights that a MapReduce task. Job complete a success, the reduced output file enriched using the HDFS code. This display output a confirm that the program execute a correct and produce aggregate result without a runtime error. The mapper extract the HTTP status code from each log entry and output a count of 1. The reduce summary all count for each status code to produce the final frequency. The driver set up and run the MapReduce job on the Hadoop cluster. The output show the HTTP status code 200 appear most often, followed by 302 and 404. This means most requests were the successful while some were redirected or missing. The result confirm that the mapping execute the status code correctly and the reduce summary them executely. Running the job multiple time give a consistent result provide the customization Hadoop implementation is stable. So for the limitation of this project is one limitation is that a small data set used to demonstrate batch processing only and not a real-time analysis. In the conclusion, this project is successful implement a Hadoop MapReduce program to analyze the web server log data. The program was adapted from the public GitHub repository and custom by modified to the log peripheral log logic and using a different dataset. The mapping extract the HTTP status code, the reducing aggregate, the frequency counting, and the driver manage that a job execution in the Hadoop environment. The output verify that the system function correctly and fulfill the objective of the individual assignment with the all sources referred by academic integrity. This demo show to execution of the project using the script run all demo sh. This script automatically upload the input log file into the HDFS and run the Hadoop MapReduce job and display the output result. Here, the Hadoop job is submitted and execute successful. The output show the frequency of each HTTP status code generated by the reduce. This confirms that the MapReduce program adapted from GitHub worked correctly after customization and produced a valid result. Thank you. This demo show to execution of the project using the script run all demo sh. This script automatically upload the input log file into the HDFS and run the Hadoop MapReduce job and display the output result. Here, the Hadoop job is submitted and execute successful. The output show the frequency of each HTTP status code generated